Here we're being asked to solve a quadratic equation. I know it's a quadratic because it has an x squared term. I'm going to be solving this using the quadratic equation that's given at the front of the paper. The clue to the fact that I need to use the quadratic equation, apart from the fact that this is a calculator paper, is that it wants the answer correct to 3 significant figures. I've got a quadratic equation equal to 0, and they want it correct to 3 significant figures. So I turn to the formula sheet and I locate this section of the page. And the first thing I'm going to do is write down what the quadratic equation is. So that is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And if you're in my class, you know exactly how difficult that was not to sing, because I do have a very good song for that. But we'll just write it down this time. So x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And in fact, in the formula sheet, they try and give you a little bit of a clue as to what you do with this formula. They say that the solutions of a quadratic in the form of ax squared plus bx plus c equals 0, where a is not equal to 0, are given by, and then there's the equation. So what they're saying is whatever is the coefficient of the x squared term is going to be a. Whatever the coefficient is of the x term will be b, and whatever the constant is, the number on its own at the end, that's going to be c. So let's look again at the question. They give us 3x squared minus 5x minus 1 equals 0. Therefore, I know that a is equal to the coefficient of the x squared, so that's 3. I know also that b is equal to the coefficient of the x term, and it looks like it's just a 5, but it's not, it's negative 5. And for c, I take the constant at the end, so that's just negative 1. Now I know a is 3, b is negative 5, and c is negative 1. I'm going to put those numbers into this formula. And I'm going to make sure that when I substitute numbers in, I'm using brackets. I'm not going to introduce multiplication signs, and I'm definitely not going to go straight to my calculator. So, x equals negative b. Now my b, I'm going to put in brackets, was minus 5. The fact that there was already a negative there doesn't matter. You don't skip one out, and you don't just put negative 5 at the start. The equation says it's negative b. The fact that my b term is also a negative does not matter. That's negative b plus or minus the square root. And again, I'm substituting b in, so I'm using a bracket, for minus 5 squared. Minus 4, I'm substituting a in, so I'm using a bracket. And I'm also substituting c in, so I'll use a bracket, that's negative 1. And that's all divided by 2 lots of, and then I'm substituting an a in there, so there's my bracket, 3. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now I just need to put that into my calculator. Oh, no, I don't yet, actually. I'll do the split. Let me zoom out. Now, the fact that this has got a plus and a minus in it means that you need to perform this calculation twice. You need to do it once with a positive and once with a negative. So here I'm going to have negative 5 plus the square root of negative 5 squared minus 4, 3 minus 1, all divided by 2 lots of 3. And for the negative one, I'll have negative 5 minus the square root of minus 5 squared minus 4, 3 minus 1, all divided by 2 lots of 3. So I'm going to perform those two calculations. I'll do the positive one first. So I'm going to enter, using a quotient, a fraction, -5, and that is this is the button here for a negative number. I'm not going to press the take away sign. I'm using negative, open bracket, -5, close bracket, plus the square root of, open bracket, -5, close bracket, squared, minus 4, 3 in brackets, minus 1 in brackets, divided by 2, open bracket, 3, close bracket. So all my substitutions there have gone in brackets. I press equals, and that's given me 5 plus the root of 37 over 6. Now that's not going to be my final answer, but I am going to write that down. So I'll write that over here. 5 plus the root of 37 over 6. I'm then going to press the SD button, and that's going to give me the long decimal answer. So that's going to be 1.84712, and that goes on. I'm not going to deal with the rounding just yet. That's my solution. That's one of my possible solutions for x. Now, I'm not going to press all clear on my calculator because I need to enter the exact same equation, only this time using a negative instead of a positive before the root. So I'm going to just press the backwards button to go back into the equation I inputted. So here I am just going back through it all until I get to the positive. Once I'm hovering after the positive, I'm going to press delete, and I'm just going to put a subtract sign in there. So now I've got -5, take away the square root of -5 squared minus 4, 3, minus 1 over 2 lots of 3. And I'm just going to press equal. And that's given me, in surd form, 5 minus root 37 over 6. And you can see these are exactly the same. The only difference is one's positive, one's negative. I'm then going to press the SD button to get it as a decimal, and that's given me -0.18046 ... that goes on. So now I've calculated my possible values for x. I need to make sure that I don't lose the final accuracy mark because they wanted it to 3 significant figures. So that's both of them. Now a significant figure is the first number you come to that does not have a value of 0. So 1 is significant, 8 is significant, 4 is significant. So there's 1, 2, 3 significant figures. I want to cut off after that 4. However, I have to respect the fact that there were numbers following it. And there's a 7 following the 4. And the effect that has is it rounds the 4 up to a 5. So that becomes 1.85. And for this one, the 0 is not significant. Zeros only become significant when they're in other numbers. So like this 0 here, that is significant because it comes after a 1 and an 8. This is not significant. This is the first significant figure. The 8 is the second significant figure. And this 0 is my third significant figure. So I want to cut my number off there. However, I must respect the fact that it was followed by a 4. And because 4 is less than 5, it doesn't have an effect on the rounding. So my answer here is 0.180. And note, I'm putting that 0 there because they wanted 3 significant figures. Okay? So there's my 2 solutions. Here's a second question for you to try. Remember, you need to start off by stating A equals, B equals, C equals, and be careful, keep an eye out for any tricky negatives. Press pause, have a go, and then I'll show you the answer. So here's a very brief run through of the answer. A was the coefficient of x squared, so that's 3. B b is the coefficient of the x term, which is negative 4, and c was the not the coefficient, c was the constant, negative 2. So I need to substitute those numbers in using brackets to the quadratic formula, which can be found at the front of the book. So I end up with x equals negative 4 plus or minus the square root of negative 4 squared minus 4 times by 3 times by negative 2 all over 2 lots of 3. I've then split it to find my positive and my negative, and then I've used the calculator to just press backspace. I've changed the positives and the negatives, and I ended up with 1.7207 and so on, which I rounded to 3 significant figures, 1, 2, 3, cut off, respect the fact it is followed by a 0, which actually doesn't change it. And the same here, negative 0.3874 and so on, cut off after the 7. I respect the fact that it is followed by a 4, although it doesn't have an effect. So there's your answer to this question. This is the final question we look at using the quadratic formula, and I think this is a really interesting question. They've already substituted a, b and c into the quadratic formula, the quadratic equation. What they're asking you to do here is to find out what the equation was originally in order to get that when the values had been substituted in. Now we need to remember x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And a is equal to the coefficient of the x squared term, b is equal to the coefficient of x, and c is equal to the constant on the end. And as always, flick to the front of the formula book, have a little look at it. Does anything spark? Alright, well, I'm going to start by writing this exact formula out next to what they've given me here. Alright, so they've given me that x equals negative b plus or minus the square root of b squared minus 4ac. The fact that this is in a bracket, don't let that fox you. Alright, it's only in a bracket to say that it's all cut in there under the root. And that's all divided by 2a. Now the reason I've written it out alongside is so that I can pick off the easy or the more obvious calculations. Like this, for example. I've got a 2a there, it's over 2a, and this has ended up as 4. So I know that whatever a was, it's been multiplied by 2 and ended up as 4. So I'm going to write that as an equation. I know that 2a ends up, when substituted in, ends up as 4. So in order to find what a is, I can just solve that for a. A cheeky divide by 2 on each side means that a must have originally been equal to 2. I'm going to keep that in the bank. Alright, that's my a term. Now let's have a look what else is the most straightforward to find. Well, straight away my attention is drawn to the b because it's just at the start. So x equals negative b, and on the question x was equal to negative 7. Now in the previous ones we've looked at, the coefficient of b has actually been a negative number. If b was a negative in this question, then we'd have negative b, which would end up giving you a positive. The fact that it has stayed as a negative means that there's only one negative in the formula, and that's the one that already existed. Therefore, it means that b must have been positive 7. If you want that set up as an equation like we did here, then I can just say, well, negative b ends up as being equal to negative 7. But I know that negative b is really just negative 1b. So in order to get b on its own, I need to divide by negative 1 on both sides. So that cancels the negatives out there, and I end up with b is equal to negative 7 over negative 1 equals a positive 7 because there's 2 negatives. So I know that b is going to be positive 7. Now I know a and I know b. I can use those to find C. Right, looking at the formula, where is C mentioned? Well, here, it's this part, minus 4AC. And what does that correspond with in our question? Negative 32. So I'm going to go ahead and write that out as a little equation. I know that negative 4AC, when substituted in, ends up as being equal to negative 32. Now, I want to find what C is. I know what A is, but I'm just going to pretend I don't for the time being. I know what I don't need there is that negative 4. So I'm going to go ahead and divide by negative 4 on both sides. So my negative 4s have gone. Now I'm left with AC, so A times C, is equal to 32, or negative 32, divided by negative 34. So there's two negatives, which means there's a positive, and 32 divided by 4 is 8. So I know that A times C was equal to 8. Now I've already found what A is. A is 2. So in fact, I know that 2 lots of C is equal to 8. And therefore I can solve for C by dividing by 2 on both sides. That means I end up with C equals 4. Now I have a value for A, and I have a value for B, and I have a value for C. I can pay attention to the fact that A, B, and C correspond to the different coefficients of the different parts of the equation. So A is the coefficient of the x squared term. So I had A as being 2. Therefore, that means my equation must have started with a 2x squared. And for B, is the coefficient of the x term, and I had my B as being 7, so that needs to be plus 7x, and then the C is what follows, and I found my C value to be positive 4, so that's going to be positive 4. And they did ask you to work out the quadratic equation Alison is solving. At the moment, that there isn't an equation, it's not equal to anything. I need to remember that I want it in the form of ax squared plus bx plus c equals 0. So I am just going to make sure I've written that out, equal to 0. 2x squared plus 7x plus 4 equals 0. I really like that question. Now, this question I've put in just to show you how they might hide the fact that you need to use a quadratic, the quadratic equation to solve quite a complex algebra problem. Diagram shows a trapezium. All the measurements are in centimetres, and you can see that they're written in algebra, so it's not just numbers. They're saying that the area of the trapezium is 351. Show that 2x squared plus x minus 351 equals 0. This isn't the part that needs the quadratic equation. I'll pause it, have a go at showing that the area of the trapezium can be represented by that equation. Okay, in order to answer this question, you're going to need to know how to find the area of a trapezium. And I'm not here to judge if you can or can't do that already. However, to help you out, they have put the formula at the front of the formula page. Area of a trapezium is half of a plus b times h, and a and b are just whatever the parallel lines are. Do not be fooled into thinking they're always going to be the top and bottom. It could just as well be the two side lines. You have to identify the two parallel sides. And also, when they've given you h, under no circumstance do you use the slopey side. It's always a perpendicular height. All right, and remember, if the parallel lines are going vertically, then, I didn't mean to put the V's up then, but if the parallel lines are going vertically, then the height is actually going to be going across because it's perpendicular to the parallel lines. However, the diagram shows a trapezium, measurements are in centimetres, and the area is 351. Show that there. First thing I need to do is write the area of that trapezium. So I know that the area is equal to half of A plus B times by h. I've copied that from the formula page. It's always a good start. And I'm going to write it out with my numbers substituted in, and I'm not going to worry about this yet, this is the area, this is what it's going to be equal to, but let's get an expression down there first. So it's half of a plus b, and they do just happen to be horizontal in this. So x minus 4 plus x plus 5, and that's multiplied by h, and the h is here, 2x. Now because I am substituting in instead of a h, I am going to put it in a bracket. Alright, so I end up with half of x minus 4 plus x plus 5 times by 2x. Now before I deal with the half, I'm actually going to multiply these, or simplify this bracket and then multiply them out. So I'm keeping the half there for now. X plus x is 2x. Negative 4 plus 5 is positive 1. And then I have my 2x. I'm going to expand this now, again holding off on the half until the end. So 2x times by 2x is 4x squared. And 1 times by 2x is positive 2x. So now I can expand the bracket by the half. So that equals half of 4x squared is 2x squared. Half of positive 2x is 1x. So I've got 2x squared plus x is the area. Now I know that the area is equal to 351. So I've written out an expression for the area and put it equal to what the area is. Now it doesn't look like that yet, but the only reason it doesn't look like that is because they've put theirs equal to 0 minus still equal to 351. I need to subtract 351 from both sides, and that will end up giving me 2x squared plus x minus 351 equals 0. And then jackpot, my answer matches up with their answer. Now part B wants us to work out the value of x. So here they haven't said we want it to 3 significant figures or any hint that we need to use the quadratic equation given at the front of the paper, but this is a quadratic. I wouldn't like to factorize it because it's got a coefficient for a start, but also because it's got this product at the end of 351, which is negative. No, thank you. I'm going to use the quadratic equation. So that's my a term. A is 2. B, and there's no coefficient here. Don't be mistaken into thinking that that's going to be 0. It's not. There would be an invisible 1 in there. So A is equal to 2, B is equal to 1, and for once it's positive, and C is equal to negative 351. I'm going to then go ahead, copy out the quadratic formula from the front. So that's x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. I'm going to substitute my numbers in. X equals negative 1 plus or minus square root 1 squared minus 4ac divided by 2 lots of a. So when you go ahead and put that into your calculator, what you'll end up with is x equals negative 1 plus the root of 2,809 all over 4. So that'll be the positive one, and for the negative we'd have x equals negative 1, take away the root of 2,809 all over 4, and that then gives me corresponding solutions of, so the solutions are x equals 13, and for this one x ends up as negative 27 over 2. Now they're solved, and yes, I have a positive and negative solution for the possible solutions of x. Now, I'm dealing with area here, and I'm dealing with lengths. Have you ever seen a negative length? No, of course you haven't. You cannot have a negative solution if you're dealing with lengths or geometry. It doesn't exist because a negative length would not exist. Therefore, you need to select the positive answer. The solution to this question is x equals 13.